Well, I want to say hello and welcome everybody to the 2021 Arkansas-Missouri Turfgrass Field Day. It's a privilege for me to be able to talk to you about some wetting agent research we have going on here at the University of Arkansas. My name is Daniel O'Brien. I'm a PhD student working for Dr. Mike Richardson here at Arkansas. And you know, if we'd been filming this a couple months earlier, I would have told you I'm a PhD student working for Dr. Doug Karcher. But Doug has gone on to Ohio State, and like everybody here, we wish him all the best, certainly miss him. And you know, I'm extremely fortunate and appreciative of the opportunity I've had to work with him, learned a lot from him. And you know, the trial I'm going to talk to you about today is one that he and I kind of designed together for Field Day. We're both trying to kind of get a talk out of it. So there are a couple layers to this, and a couple different angles to look at it. I'm going to try and do my best to talk about all of that. But you know, in the simplest terms, this really comes down to what are the measurable differences between wetting agents? This question of what are the differences between wetting agents, I think is a real valid one, and it's one that we want to investigate. But you know, to turn that big question into a more manageable research objective, we've got to narrow it down a little bit. And you know, when I first started talking to Dr. Karcher, he would kind of describe what he wanted to do as a run-out study. You know, we're talking about differences in wetting agents, and he was kind of thinking over the time scale. Well, at what point do these products stop being different than an untreated control? You know, what does the breakdown look like? Does it happen for all of them at the same time, or do certain products run out of gas before other ones do? So really trying to kind of add a time component to what we're looking at is a big part of the research I want to talk to you about today. The other side of it is, you know, where does the water end up? We're talking about, you know, using wetting agents a lot for managing localized dry spot, but that's not the only reason people use these. That there's, you know, a big push to really move water to desired depths or to hold it at desired depths within the profile. So, you know, we'll hear terms like penetrant and retainer. And honestly, you know, those are terms that are a little more marketing based than research based. We want to go out there and we want to say, okay, does a penetrant really move water deeper than a retainer? What are the differences in terms of where the water ends up? So, you know, the kind of measuring the differences between wetting agents over time and space is really at the heart of what this research is all about. So to kind of show you what we've got going on here, behind me, this is one rep of the trial we have going on, this run-out study, and there are 13 different rectangles behind me. And each one of those rectangles is a different wetting agent. Here's a place where it may be helpful to look at this from an overhead drone image. First of all, we're conducting this research on one of our sand-based USGA putting greens in a block of flagstick creeping bent grass. Now within that rectangle, what I hope you can see is there are 6 smaller squares, and each one of those is an application strategy. So we're taking each one of these wetting agents and we're essentially applying it 6 different ways to sort of see what the effects are over time and space. There are 13 plots out here, and the reason there are 13 is because I didn't have room for 14. You know, I could have put as many products in this trial, and there's honestly some that I would love to continue this work with, but we're trying to decide what belongs in this trial. We went back to some of that penetrant and retainer work that we did with the GCSA previously, and we had tried to identify, went to the different wetting agent manufacturers that were out there and tried to kind of get their pairs, so to speak, of penetrants and retainers. So we pulled back some of those products, like for example, from Aquatrols, we've got Dispatch and Primer Select. From Turf Fuel, we've got Cleanse and Kraken. We've got some Precision Labs products in there. We've got Harold's, Florentine pairs of penetrants and retainers in there. So overall, 5 different pairs of penetrants and retainers, but we also wanted to include some things that weren't necessarily being marketed as a penetrant or a retainer, some of the more industry standard type products, I call them, just established products that are used for different purposes, like Revolution, Tricure, and Cascade Plus. So those are in here as well. So altogether, like I said, we have 13 different wetting agents, and we have 6 different ways we're applying each one of those. And just to kind of talk about it in general terms, just to pick one of them right behind me, you know, if we're of the application strategies, the first application strategy, I guess I would say, is no application at all. We've got an untreated control in there, so we can compare using these products to not using them. The second way is to use it at the label rate. If we're going to use these products, it's only fair to evaluate them the way the manufacturer tells us they should. But, you know, through Dr. Karcher's experience and my own, just hearing from superintendents, they don't always think the label rate works best for their situation. Some people would say, hey, look, I can apply this product every month, but I see the same results if I just make one application at the beginning of the year. There's no difference. So the idea of making a single application compared to the label rate, it was something we very much wanted to do. And then, the flip side of that coin, we'll hear some people say, I can apply this thing, but the first application, I got to go twice as heavy just to get it kick-started. So a single application at a 2x rate is another one of the strategies we've got in here. And then, we would hear some people say, look, I'm going out every month, but I don't need to use the full amount that they're telling me on the label. So we have a monthly application at a 1.5 rate, a half X rate. And the last application strategy we have in here is that some people would say, well, I'll go out with this thing, I'll make repeat application, but I don't need to go every 30 days. I can wait 60 days before I need to reapply. So having a reapplication interval that's twice as long as maybe what the label says is another strategy that we have. This trial was initiated on May 13th, which is the one time that all of our treatments were applied, and it made for a long day. But if you were here early the next morning, it also made for some really impressive dew patterns. And I want to point out that one thing we've started doing with our wetting agent trials is to surround each plot with a border of untreated turf. Rather than individual plots bumping right up next to one another, each plot is on an island, so to speak. So it makes the localized dry spot pressure equal, regardless of whether plot's located on the outside of the trial or within the middle of the trial. And this new experimental layout, it seems to be a good thing. It makes for a lot of striking images, both in dew patterns and following treatment applications. So in terms of data collection, when we're talking about wetting agents, it starts with water. And on all of our trials, we're really interested in being able to quantify the effect of these wetting agents on the water that's available to the plant, the water that's there in the root zone. So we're using the TDR meters from Spectrum. We've got the TDR 300 and the 350, but we're trying to make sure that we're measuring water not just at a single depth, but we're really trying to map water vertically throughout the profile of these greens. And it's of interest for water that's available to the plant roots as far as plant health, but it certainly has implications for playability as well. Are these wetting agents, there's a lot of talk about keeping the surface too moist and having, softer surfaces because of wetting agent use. So all of this kind of ties together in where does the water end up and how does the water behave differently based on the wetting agent that we're using. So you can see we're coming around with 4 different depths for this particular trial. We've got the 1/2 inch depth using their spacer block, as the shallowest depth. Then we're measuring at 1.5 inches as well as 3 inches. And then we're taking it down to use their 4.8 inch rods, as our deepest depth out here. And within a plot, each one of these little squares that I was showing you as far as the application strategy plots, they're 2x2 plots. So we've got 4 square feet. We're going to take a measurement every square foot. So we're getting 4 readings at each depth per plot, and then we're going to go through every plot in the trial, which it amounts to a lot of data collection. So we're using digital image analysis like we always have, but we're also trying to embrace some of the newer technologies that are out there in terms of capturing some digital image analysis from the air. This is our Matrice 200 drone from DJI that we're using, and it's outfit with a Altum sensor from MicaSense. So what I really love about this Altum sensor is that it's going to give us a photograph just like our digital camera does from the light box. It's going to capture the visible light that our eyes see, but it's also going to capture some light that our eyes can't see, something in the infrared, near infrared spectrum, so that we can create some plant health indices like NDVI or NDRE. You can really get a better handle on overall turfgrass health or stress by being able to incorporate some of those things that our eye just can't see or that the camera just can't pick up. The overall challenge of all this is we can capture a lot of data. We can capture a lot of images from the sky, but understanding what they mean on the ground level is a big part of really making this technology work for us and making it practical. So, like I said, we're trying to do our data collection weekly, and we're trying to make everything happen on the same day. Where once the green's mowed, we'll come out here and we'll fly the Matrice, and we'll capture all the images that we need in a pre-planned flight, so we can go process those data and create some big orthomosaic images. And then we'll roll through with the light box and we'll take an individual image of each plot so we can correlate the images taken from the air with the images taken on the ground and really begin to speak to turfgrass quality. And then, being able to use some of those NDVI numbers to talk about the moisture that may or may not be there in the turf and where it is. So really trying to put all this data on top of each other within the same day has been a big part of what we're trying to do with this trial. We need to speak the language that our turfgrass speaks. It doesn't speak in terms of days, but it understands, the temperature, the environmental conditions. So, the last piece of data collection equipment I would say, is the weather stations that we have out here at the Research Center in Fayetteville, where we're going to really try and evaluate all these measurements, the turfgrass quality, the changes in moisture, by going back to look at, what was the ET or growing degree days. Dr. Bill Kreuzer up in Nebraska has done, just great work, been a game changer for how we think about reapplying PGRs. And, the idea is that speaking that same language as the plants is really the right way to do it for a lot of products. When you talk about where a wetting agent goes and why it stops working, there may be a rainfall element to that, but a lot of the discussion centers around microbial activity. These products, once they're applied and they're in the soil, at some point the microbes get to them and break them down so they're no longer effective. And growing degree day makes a lot of sense when you're trying to track something like microbial activity. Here in Northwest Arkansas, for the most part, we've had a pretty bentgrass friendly summer. Rather than show you some big weather chart comparing this year's temperature and rainfall to historical averages, I thought this image summed it up pretty nicely. It was taken on July 23rd, and our bentgrass greens being mowed at 125, 6 days a week, have 6-inch roots on them. So the LDS pressure and moisture stress on our wetting agent plots is a little behind where it might normally be this time of year. The way we typically run a wetting agent trial around here is that early on in the season, we don't want to lose turf too early. We want to evaluate these products over a range of moisture conditions. So we're irrigating heavy, almost to the point of over-irrigating, replacing about 100% evapotranspiration, ET, to try and see how these products perform there. And gradually, as the summer goes on, we'll kind of ratchet that back. We'll dial it back to 90%, bringing it down to 80, and after we get to that point, when we start to go below that number, we really start to see some stress on these plots, and quite frankly, we're just not there yet. Not to ruin any of the field day movie magic, but I'm talking to you, and we're still a couple weeks out from turning the calendar into August right here, and that's typically when we can get a little more aggressive with the water restriction. So we do hope to see some more localized dry spot development. We're starting to see it kind of here in just a couple plots. A good wetting agent trial, you're always going to see the controls flare up first. The products will continue to work, but the untreated controls will really start to show you those LDS symptoms out in front of everything else. And then, be interesting to see how some of those single applications or the half rate applications compare to the control in terms of when they start to show up. Ultimately, a great way to appreciate all the data we're collecting and wetting agent differences is through maps. So as our data collection continues to come in and as we apply more and more stress to these plots, we want to construct different types of maps which speak to our objectives of evaluating turfgrass quality and measuring volumetric water content. Not only between wetting agents, but within a single plot within a single wetting agent in terms of how it's applied. Again, this is our first year of the trial. It's a little unfortunate there's not more to see here on field day, but we're moving into that part of the year where I certainly expect the differences to become more pronounced. Treatments and data collection are going to continue through September, and we're going to be able to build maps from every one of those data collections. We're going to continue this work again next year, at which time hopefully we'll be back to having an in-person field day and be able to present a lot of results to you at that time. I certainly appreciate you attending field day this year and giving me the opportunity to share some of my research with you. The only reason I'm able to do that is because of the people listed here. It truly is an awesome group in the turfgrass program at Arkansas, and I am extremely grateful to be a part of it. Thank you so much to our entire group for helping me day in and day out. And here are the details for some of the articles I referenced earlier. And the last thing I want to say, I know field day has been a little different this year, not being able to do this in person and not being able to offer the usual pesticide recertification credits. So I do want to make sure you know about an upcoming opportunity to acquire pesticide recertification, which will be at the Arkansas Turfgrass Association Annual Conference in Hot Springs. This is going to be an in-person meeting, January 26th through the 28th. We're working to bring in speakers from across the country as well as within Arkansas to present as a part of our educational program. There will be a trade show, and again, pesticide recertification for Arkansas, and we're working on being able to offer recertification credit for all adjoining states, including Missouri. So please save the date, January 26th through the 28th, 2022, and keep an eye on your inbox for some more details. Thank you again for being a part of Field Day today, and if there's time, I will do my best to answer any questions. But even if you don't have a question here today, my contact info is listed, and I'd love to hear from you. In order for my research to be meaningful, it needs to be meaningful to you and address the things you're interested in. So anytime you want to talk wetting agents or anything else, please drop me a line.